The Hindenburg did not simply explode because it was full of hydrogen. That's the easy version. The real story is more interesting, more scientific, and honestly more chilling. On May 6, 1937, the German airship Hindenburg was preparing to land in Lakehurst, New Jersey. It was massive, longer than 3 football fields, and filled with hydrogen gas, which is extremely light, extremely useful for flight, and extremely flammable. But hydrogen alone does not burn unless it mixes with oxygen and meets an ignition source. So the key question is not just, was there hydrogen? The real question is, how did hydrogen, oxygen, and ignition come together at the exact wrong moment? As the Hindenburg approached the landing field, it passed through stormy, electrically charged air. The ship had also released landing ropes, which became wet from rain. That matters because wet ropes can conduct electricity. The metal frame of the airship could become electrically connected to the ground before the outer skin fully discharged. That creates the perfect condition for a spark. Now add another problem. Hydrogen may have been leaking near the rear of the ship. Witnesses saw the fire begin high toward the tail section. A leak could have come from a damaged gas cell, possibly stressed during sharp turns before landing. Once hydrogen escaped, it mixed with air. That mixture is dangerous because hydrogen burns over a wide range of concentrations in oxygen. It does not need much encouragement. A small electrostatic spark could ignite it. Chemically, hydrogen combustion is simple. Hydrogen reacts with oxygen to form water vapor, releasing a huge amount of energy as heat. That heat then ignites more hydrogen-air mixture nearby, and the fire spreads rapidly upward and forward through the ship. But what about the airship's famous outer coating? Some theories claim the skin itself acted like rocket fuel because it contained compounds similar to materials used in explosives. The truth is more careful. The coating may have burned and contributed to the visible flames, but the speed and scale of the disaster strongly point to hydrogen as the main fuel. The skin was not the first cause.
It was more likely part of what burned after ignition began. So the most likely reconstruction is this. Storm conditions created electrical charge. Wet landing ropes helped produce a voltage difference. Hydrogen leaked into air near the tail, and one spark triggered combustion. And in just over half a minute, the largest airship in the world became a lesson in how invisible gases, tiny sparks, and basic chemical reactions can change history. Like, share, and subscribe for more science behind historic disasters.